Okay. Now, I'm sorry, guys, we were rushing right there at the end. There we go. All right. So the distance for the helicopter is 180 times t plus a third. The distance for the plane is 330 t. Now, here's the real question. Here's the real question. Grace, do we have to, or in this problem, are we wanting to add these two distances together to find a total distance? Or are these two distances equal to each other? They're equal to each other because the plane is trying to catch the helicopter. They're traveling the same distance, right? It's just the plane leaves later. So when I set up my equation, I'm going to say that 180 times t plus a third is equal to 330t. Okay? Now, Kyle, lead us through this. Now we just have an equation. Let's solve for t.
Now you're going to, on the left side, you're going to distribute.
Okay, on the left side I'm going to distribute. I'm going to get 180t plus, what's 180 times a third?
60.
It is 60. All right, thank you, Parker Kyle. Okay, 330t. Okay, now Parker Allen. You're welcome to just answer in front of him if you'd like. Parker, where do I go from here?
Minus 60.
No, I'm going to leave 60, Kyle. All right, Parker, what do you think?
How about we subtract 180?
Let's subtract 180t. Let's get those variables together. Okay, and I'm going to get 60 is equal to 150t. Okay. Emily, where should I go from there? I don't want to divide 150 by 60. Divide 60 by 150, or divide by 150 on both sides. Okay? So I'm going to get t is equal to, and since we have terminal zeros, they just cancel each other out. So I've got 6 over 15. What does that reduce to, Clay?
That reduces to
6 over 15 reduces to what?
3/5. No, 2/5.
2/5. But remember, that's 2/5 of an hour, which is fine. But what is 2/5 of an hour, Sophia?
0.4.
Is
that 20 minutes?
It's not 20 minutes. What's a fifth of an hour? What's a fifth of an hour? What's 1/5? 12. So what's 2/5? 24 minutes.
So can we put 0.4 of an hour?
0.4 of an hour? Yeah, I would accept that.
Okay.
I would. That'd be fine. Okay. All right, let's look at the next one. Let's see how many we can get in this. All right, number 19 says solve the problem. A rectangle is 3 times as long as it is wide. If its length and width are both decreased by 2 centimeters, its area is decreased by 36 centimeters squared. Find its original dimensions. And then I couldn't cut this off, but there you go. All right, we're going to make a sketch, obviously. All right, so here's the original rectangle. And they said that the length of this thing is 3 times the width. Okay? Now, they also said that if its length and width are both decreased by 2 centimeters, so I'm going to draw a little rectangle inside here, right? I don't have to draw it inside. That may even make it a little more confusing. Rather than doing that, let's just draw it out here separately. It's just a little smaller. Now, what's the length down here now? Cecilia? 3w minus 2. And Cecilia, what about this one? W minus 2. Now, how can I represent the area for the original one? Jordan, how can I represent the area for the original? 3w times w. Do you mind if I just say 3w squared? That's going to be the area of that one. How do I represent the area for the smaller one now, Sophia?
3w minus 2
Ooh, 3w minus 2 times w minus 2. Now my equation's almost ready, but I'm running out of time. So let me pause here and we'll finish this one up on the next video.